We're doing a Neo4J tutorial today, and um, I haven't put it into the obo-academy docs yet, but so that still needs to happen. I need to copy it there. We'll paste the link in the chat to it, and then maybe someone can copy that over to the obo Slack too, so it'll be present for someone who hasn't logged in yet, or we can just paste it again. Um, uh, so the other thing I was a little unsure of is whether to go through the setup at the beginning or not, and I don't want to break my running Neo4j, but I'm going to run through the setup steps and then hopefully get to the point where we have an error because it's already running, and I think that will hopefully be good. So I'll start out. What we have here, I'll go up a step. We have a Docker Compose repository that has the configuration necessary to start up a Docker container running the Neo4j of the Monarch graph, and instructions on downloading the data, and it knows how to load the data in, which is very convenient. So I'll start out with the checkout and the download. And while this is downloading, which will take a little bit of time, I'll say, like, interrupt me a lot. I sort of took a guess at some queries and some things to say about it, but I'm very happy to wander off in different directions if people have questions. So the other thing I can say while we're downloading is that this new graph is much smaller than the old Monarch graph. And so there's like some pluses and minuses of that, I think. And every time I see there's a classic Monarch slide showing a grid of sources and the size and number, the 35 million nodes or edges that it was or whatever. It's smaller than that. But the upside of that right now is that it is very easy to download and run locally. And so, this will be downloaded in 3 minutes. And the other upside of that on our end is that it takes 2 hours to build instead of 2 days.
So when you, Kevin, when you say this is the size, is this because an executive decision was made to not include certain sources because they are sort of out of scope, so we narrowed and focused the scope a bit? Or is it because some of the sources that we want to deal with haven't been dealt with? Or why is the current Monarch KG smaller?
I think it's potentially both. So I think it is a narrow focus, and so it's really I would say, because I don't know everything that was in the old graph that well, but we don't have variance, and so I think that's probably a huge part of the size, and then a sort of like complexity thing, a reduced complexity thing, is that we don't have genotypes yet. And I'm not sure how those will end up getting represented. I don't know that, I'm not sure. I think we're still in that process, I guess. So it might, we may gain some of those things. And I think it'll be a balance. I think the other is that we may have different versions. And so maybe we may keep a core that's small and easy to download, and then have larger versions that have everything else.
Thank you. Excellent.
Okay. So the next step after downloading is you'll have this file .env template. And you can copy that to .env and edit that. And you have to uncomment this do load equals 1 and it's Neo4J dump file name. And the other thing I didn't do was move the dump into this dumps directory. And I'm tempted to open Docker and just delete my other one and hope this works. Well, okay. The next command that you run, it's not in the doc, is docker compose up. And I open Docker, it's actually, it does clobber the old one, so it is loading afresh. Okay. And I'm going to the web interface, which is localhost 7474/browser. And then I have to just say connect at this login screen and don't enter any username and password. And so the basics of this web interface, if you open up this little pancake icon, I guess that's a data, I guess it's the database icon. It will show you the node labels, how many nodes are in the graph, and then we'll also have your edge labels down below, and how many edges are in the graph. And so you can see that right now, 600,000 nodes and 4.5 million edges. And I think as we do some QC and fix some things, that's going to go up even with the sources we have. And start on some querying. So the basic structure of a Cypher query is that you get to draw, well, basic structure is that you represent nodes in parentheses. And so in the basic sort of structure of a query is you sort of say what you're going to match and what you want to return from that match. And so we can match a single disease by Mondo ID. And the results, you also have the option to view as a graph, and then table and text forms also. And I only recently learned about Achu syndrome, and it is my new favorite Mondo term. And if you don't know, so it is paroxysmal sneezing when you see sunlight. And I like that great kids book, Tuesday at the Beach, by Neil Gaiman. I highly recommend it for a story about Achu syndrome. Let's see. So we can, without doing any extra querying, we can see extra associations. So clicking on this bubble lets you click on this graph. And if I open that up a little bigger, you can see this wonderful, let's see, zoom out, this wonderful tiny graph of what is connected to Achu syndrome as one phenotype. My Zoom furniture as one phenotype that is unprovoked explosive pathological sneezing, which honestly that would suck. And then it has this subclass of relationship to Mendelian disease and has mode of inheritance relationship to what's the name here? Autosomal dominant inheritance. But if we want to query to get those connections out from the beginning, we need to draw this little sort of ASCII art picture of a node, or a relationship in the brackets, and another node. So I will paste that in. And we get the same picture here from the start. And that same ASCII art can be expanded another step. And there's another reason that Achu syndrome is a wonderful example is that you can expand it out one more step and it's still a nice little readable graph. This follows out that the paroxysmal sneeze is a subclass of sneeze, that autosomal dominance is a class of mode of inheritance, and then it follows up from Mendelian disease to just human disease, and inherited is related to. And what's important to note there is I didn't restrict the subtypes at all. So the thing about the Monarch, or think about any Neo4J graph as you pick it up, is that you kind of need to know what's in it and how the things are connected. And this panel, it helps you out because it's, it's what are all the node types, what are all the edge types, but it doesn't tell you a lot about how things are connected. And it's hard to make a lot of use of Neo4J without, it's hard to write a query when you don't know how things are connected. So there is this built-in method for schema visualization, but you can if you zoom and you kind of tug and pull, like you might be able to learn a little bit from it, but it's just a hairball. So I don't tend to recommend that. But what you can do is write queries to teach you about the connection. So in a query, you have the option to return not just the whole object, but text, plain just text instead. And so what this query is asking for is bring me back a gene, any connection to another node, and skip that. I want labels of n, and so that's a built-in function that will get the category. And then distinct means I don't want you to repeat that over and over again. So just limit down to the unique set. And if I run that, makes the text version a little nicer. Then I can see these are all of the kinds of nodes that are connected to a gene. So there are other genes, there are pathways, there are a component, a typic feature. And then taking that one little step further, you can give a name to the relationship. And then there's a second built-in function called type for relationship that will do the kind of relationship it has. And from your starting point of gene, then you can see that there are connections out to, say, located in a cellular component, active in a cellular component, interacts, a gene interacts with a gene. And so another thing that you can do then is constrain both both of the nodes and see the types of relationships. So this lets us see the kinds of relationships between genes and diseases. And this is actually also a change in the graph that we have, thanks to Sabrina's work. We have risk affected by and gene associated with condition rather than causal and whatever the other one was in the old graph. And so risk affected by is the stronger association, and the weaker association is just gene associated with condition.
Yeah, so, question.
Yeah. Yes.
The risk affected by it seems to be a relationship from disease to gene. What is the directionality of that rel? It looks like it's pointed gene to disease, but does it return the other direction as well? Maybe I'm not reading it right, but risk affected by sounds like it'd go from disease to gene.
It does, doesn't it? The gene. Yeah. Yeah, it does sound, it does read backwards to me.
But the query should only be the direction of gene to disease, right? There is directionality in there, like it looks like there is. So
yeah.
Need to look into in the graph or rename that if it is truly meant to be a gene to disease relationship. Something to look into later.
Yeah, that makes sense. Yeah. Check out. I mean, or we're using it backwards, but yeah. I agree. Thank you. Let's see. So where's it going like that? Anyway, so I guess the next sort of like unfurling out was gene to disease to phenotypic feature. And I think this is going to be like one of those times where finds a bug. So
Kevin,
this is unexpected. Yeah.
1 second before we go into the gene to phenotype ones. So for this, just because some questions came up on the schema visualizations. So this schema visualizing tool, I didn't even know this existed, but do you know whether it's possible to take the result of this and just continue to narrow it down? So for example, give me the schema portion related to the BioLink gene class or something like that, or have you not ever tried that?
I tried, but yeah, that's where I was going to go. And you can't, I couldn't do like a limit or a where clause on it, I think. Okay. I don't know if I definitely tried limit. I kind of thought, well, give me 5, and it didn't do that for me. Okay. So yeah.
And the second question, just for the nature of this that Ian was asking, is it like, is this supposed to be showing all of the kind of relationship types broken down by the like high level, so by the node labels? So basically every time you have like different node labels and different relationship labels, let's say, it will draw a line between those in the schema visualizer. Is this what this tool is doing, as far as you understand?
Oh, the DB. I think so. Yeah. Okay. Good. So, but I honestly, because I couldn't constrain the output, I kind of moved on from it pretty quick.
No, that's good. It's good to know, and I think it is a really important problem for many of us actually. To someone says, here's my knowledge graph, or just for debugging purposes, actually we want to sort of look at what type of information does it actually contain. And I think it is actually very, so if you were to remove, for example, named entity from this, like schema output, I think it would look already much cleaner. And if there was a way to sort of constrain it a bit more, I think you could use it to generate very valuable information for understanding what the structure of the graph is in the end.
Yeah, I actually wonder, I said, and the labels, I think this is maybe KGX when loading, adds the closure of categories. But we building the graph, we're only putting the leaf category in on the node. So actually, if I do it this way with n.category for this, then it's still wrapped in a list, but they only have single values.
That shouldn't be the problem then, what I said. Okay, and just lastly, just for completeness, you are using BioLink model. I think that this looks really, really neat everywhere. Is it the case that every relationship is a type of BioLink relation, and every node has at least one BioLink category in this graph?
Yes, almost. I think there might be some things that maybe have like a blank category still, but that's the intent, is that everything would be BioLink. All the associations are BioLink, and all the categories are BioLink. And it is a little unfortunate that it means you have to use this sort of backtick syntax around things. For usability, I feel like it really would be, it might be nice to load it, to strip the prefixes off. I don't know, that might be heresy, but I think it would definitely be easier to work with.
Thanks. Yeah,
Kevin, one more quick follow-up about the schema visualization command. If, one of the problems with really using that is you can't visualize the hairball. Is there a way to output this as a table, like a 3-column table of just kind of triples?
Oh,
right, because then you could really just get a nice list of the different, like, meta types, we call them in translator, meta types of edges in the graph. I don't see like tabular formats here, right? But I know that you had some other command way to output tables.
There's a tabular
you may have to deconstruct that output a little bit, because I think there definitely should be a way to filter on the text output.
Yeah, and I mean, you kind of see like why limit and where and that sort of thing didn't work, because it just returns it as 2 entries.
Yeah,
it would just be neat if you had a 3-column table that could split out each kind of meta edge type in the graph. Then you don't have to deal with the hairball. So there's got to be a way to do that, you'd think. But anyway, we don't need to get hung up on that now. Something to look into maybe.
Yeah, I think so. I mean, the other is you could probably wrap this and make something nice. Let's see. I have the chat open now. I didn't have it open before.
No worries. We will look at the chat for you and to interrupt you if there's anything relevant.
Yeah, I'd like to suggest that the non-BioLink prefixed categories can just go in as labels, and that actually would be I think that would sort of solve both use cases really well. Let's see. I'll kind of wander back in to this a bit. So I did my query and surprisingly didn't get anything back. So this is a gene constrained to a particular gene, and it's heading through a disease and then going to a phenotypic feature. And I expect that gene to have things. And so I just sort of captured my debugging steps as I did the tutorial. And so this was also kind of a QC exercise for me. but here it's just take the constraint off of the last node. And what I learned is I do have plenty of phenotypes, but they're marked as phenotypic quality right now, which I think is probably a buzzing to file. And I put it in the tutorial, but there's a feature that I learned about that I kind of want to show, even though my like Neo4J web thing has sort of is doing the right thing right now. You can, so you click on a node, you get the categories over here, you click on the category and you can choose what the caption, which field populates the caption as a label in the visualization tool, which I think is super convenient. It was displaying like not the name for something for me. But anyway, so phenotypic quality turned out to be what I had. So anyway, so there is a I guess what did I say that you can understand this is like a semi-manageable hairball. That's worth. And so anyway, so rephrasing the query to keep constraints, it is constraining instead by the association type and not by the and then this gets me the intent of my query. So I have the BRCA1 gene, its connection to diseases, and the phenotypes between them. A phenotypic quality, I think Sierra's here question, what is phenotypic quality? I think is that Pareto terms?
Yep. Mm-hmm.
Yeah, so I think so. So that's just those nodes are getting labeled wrong. So that will get fixed. So what direction? Oh yeah, so sometimes you don't know how many steps you want to travel, and let's see. So sorry, I didn't practice this, so I'm reading each section as we get to it. So if we want to get okay, sorry. Our question, what genes affect the risk for inherited auditory system disease? And first step in that is, what are the associations between diseases? Because I know we want like subclass, and we want to traverse up subclass, but I don't remember what it's called. And so I can get all the associations, all the predicates between them, and okay, subclass is called BioLink subclass of. And we have an omen bug, and it shows up in a few places on this. And so we're making gene to disease associations between that are disease to disease and gene to gene. We'll get it fixed soon, but it's showing up with some predicates that don't belong in places, and I left them in here, but yeah. Types of interactions in the graph view. Yes. So if the question is there a way to filter out interactions in the graph view? I just queried my favorite, and it gets full of ortholog relationships. And you can, let's see if we have an example of that. It's lost now. well, I'll take this query. So
I just added my query otherwise in the chat.
Oh, yes. Thank you. This is the Zoom copy being weird, isn't it? Okay. There. Okay. I'm curious if anyone else knows. The first thought I had on this is like, I don't know, like, it makes sense. We want to subset the kinds of associations, but it's hard to see the list. So, I mean, so I guess the first thing first thing I would do with this, I think, is name the relationship and just what are the relationships, and then I'm curious if anyone else knows. Oh, Sarah has a suggestion.
It's a little
Ooh,
funky.
excluding. Yeah. Where? Where none runs type rel equals, and then probably we need to it's not named anymore.
It's not exactly what Sierra syntax is saying.
Oh.
Are you looking it up on Stack Overflow, or are you checking it from Sierra's comment?
Oh, checking from Sarah's.
Yeah, there's
well,
this
even I'm missing-
rel in R where that is missing before that. So just after the non rel in R where. Yeah. So and it's still missing. So rel in R and then another where clause. In R. So after so this rel in R where. So yeah, exactly. Where type rel equals. Yeah, I think that this looks correct. But maybe in this case, you don't need the backticks here. You need the normal quotes for the relationship. Yeah. Looked good. Maybe I'm missing. No. Do you see anything, Sierra, that's wrong here? It looks okay, right? And where? I know. So then,
that none is it's going to iterate through all the relationships. So I think you need that where R and rel.
It's removed again.
Like a
sorry.
subquery, I think, but you know the syntax is a little fussy, so you might need to say return R, or you might need to put to use something other than rel, since you're specifying rel in the outer query. You know, live demo. But I think it's
no problem. That's
with that Stack Overflow to just sort of follow along with your query and offline and see if you could get it to work. But
yeah, try this. So now it's just the variable R is not defined. It's
was R the outer one?
Yeah, probably. The R must be the other one.
Yeah. I'll put that into the return also.
A bit of cipher hacking is always good.
Yeah.
anyway, something like this will be will be correct. So it's I think.
And I mean, I suppose the other way to do it is that you can definitely you can definitely enumerate the ones to include. And I believe that is I'll do a couple of them. I think it's a pipe in between. If I need to be backtick this time. Column. Just two of them. Is it the colon before each one, I think? And so you can definitely chain several. It's just a bummer they don't have a nice little like caret or something, some syntax to say not this association. Okay, head back into the tutorial. Let's see. So cursive section, and paste this query in and take it apart. This is a query that fixes the disease, which was inherited auditory system disease. And so take a high-level disease term and then follow the subclass of association, and we're following it upstream. So this, in some ways, this query is written a little bit, is almost maybe more readable, written in the other direction, but fixing this disease, we're traversing down the subclass association to other disease, and with this star, we're traversing as many hops as there are. And then we're constraining our relationship between the disease and the gene to only include risk affected by, so only the stronger association. And then to just avoid the hairball right now, it's returning a table, or it's returning the IDs and names of each. Which I included the upper disease and the more specific, just to sort of have that confirmation that these look like what you would expect, the kinds of hearing loss that are children. And then where do we explore from here? And then, so from here, we can constrain this more and get just the distinct gene IDs that are a gene associated with a child of this modern term. And so we can explore gene to gene a little bit also. And these are the kinds of gene to gene associations we have. Two of them don't belong there. So we're going to explore the Diablo gene, because that's a cool name. And that was in our list of genes that that affect risk for autosomal hearing diseases. And so there's a query to get all the orthologs of that gene. And this is an example where I guess it kept my edit, but I did edit, and this initially showed gene name. And I looked at that and I thought, why do they get the same node every time? And so this is a great chance to switch over to this field. So this, let's see, like, okay, yes, I got my human disease, and I've got a rat and a mouse, 2Z fin, and what is that, like Diablo A, Diablo B, and rat, and switch my back to symbol. Now I can see Diablo B, Diablo A. And then, so to sort of follow into a more interesting question, what are the phenotypes of Diablo? And so I'm following orthology to another gene, and then constraining on the association type to phenotypes. And like, it's not, this is like no phenotypic, no abnormal phenotype. Thanks. Nothing to see there. And so it sort of has an alternate route to sort of maybe confirm our queries above. We're going to look at expression. So the Diablo gene ortholog relationships to another gene, and we're following the expressed in relationship. And this is like sort of a relatively manageable hairball, I think. This is an opportunity again. We go to let's go for, see, here's our human gene and its morphology associations, but got these sort of distinct sets of bubbles, and maybe we want to tighten that up. And so we can do a match through orthology to the gene expressed in, and then let's get Uberon terms to normalize our anatomy. And we'll just get the ID and the name of the Uberon terms. And happily, I scroll through my list. It is nice to see that Diablo is expressed in the cochlea. I think that's all the prepared queries I had. Does anyone else have any other exploring or like other favorite Neo4J tips to share?
One thing that would be definitely, first of all, this was absolutely awesome. So thank you so much for taking the time to prepare this. This was amazing. And I'm so glad that we now have actually a video also that we can give to newcomers that they want to start, like just getting a sense of what is in Monarch KG and want to play a bit with the graph structure as well, and not just looking at the graph in sort of an abstract manner on the website. So I think this was excellent work, and thank you for this. From like the technical perspective, I think one thing that would be also sort of cool would be to try for people to learn a bit how to play with the advanced like Neo4J features, like for example with some of the people here like Emily and Ian, we have been playing a bit with like semantic similarity in particular. And I just want to make a note here that it's too much work now to set this up, but that it's pretty easy to actually now, given this graph, to explore the graph, you know, according to semantic similarity on all the nodes. So you can just use like a structural semantic similarity notion, which is based on incoming and outgoing edges, and sort, let's say, all the phenotypes that are similar to another phenotype, or the diseases that are similar to another disease. And maybe there is something interesting there, just, you know, exploring it this way. And I just wanted to, yeah, drop this in here.
Yeah. Maybe you have a follow-up on that. I initially did some documentation on installing plugins in this sort of Docker Compose way of getting Neo4j and getting the graph. And then you know, ran into the fact that I haven't used any of the plugins yet, or done any of the cool graph querying. So I wasn't very well set to teach it, but yes, I think it'd be great to do a follow-up on using those tools on the Monarch graph. Maybe we can rope Tim into it.
Yeah, my questions are very boring, so I'm just going to wait until other people ask their questions first, because it's very, very technical. I'm sure that many of you at least will set up their Neo4j now and load Monarch KG, and that it is so easy. Who would have thought? Yeah, I agree.
Yeah,
here.
I do. I think it would be nice to work out what Neo4j artifact, or how we should supply Neo4j to make it easy to load into the desktop version, because it seemed like plugin install is much easier in that. In general, it's just easier to get started, and so I think that might be something we should work out. Is it easy to load a Neo4j dump in the desktop version?
It should be the same as here, right? Like, I was going to ask you exactly what is a dump. So is it a series of Cypher queries, or what is a dump exactly?
It's there's a command to sort of archive, like backup and restore Neo4j databases. And the database engine has to be off for it to run. So so in our Jenkins job that builds the KG, we kind of like we run KGX to install into a Neo4j database, turn it off, and then run the dump tool, the Neo4j, I can't remember the name of it now, to sort of make that dump file. And then this Docker Compose or in our repository, I can show.
Yeah, I think
there's a custom
script, yes.
a custom a Docker entry point. Yeah, Neo4j admin.
That is basically the only limitation, and it's easy to fix, obviously, but I think that we should figure out how to do this. I mean, I think the Docker approach is totally fine, to be honest. Like, most of the people that are working on a technical level will be happy to follow this tutorial with the Docker instructions. I think the only limitation here is just that you have to have Neo4j admin installed, and I don't know whether installing the Neo4j desktop version automatically also installs Neo4j admin, but if not, it's simply a separate tool that needs to be installed, and you can just load the dump, you know, on the command line with one command we just documented. So I think the good thing is, so I have been kind of like promoting using sort of like a, you know, because we're dealing a lot with like ontologies and RDF dumps and stuff, to use this neo-semantics to load the RDF straight away. But what you just showed me here is just like orders of magnitude faster. So it's like so much faster that I think it's almost stupid to you know, especially if you want to repeat it very often, to use neo-semantics for loading RDF dumps rather than, you know, shipping a dump like that. and adding it to the standard outputs also of the Neo4j of the Monarch KG pipeline, so that people can just go get the file and boom, put it and load it into a Neo4j instance. I think it does make a lot of sense to make this a quick thing to do.
The other thing that we may be able to get to for our command line data access tool, we have it will run Solar in the background. So if you can just sort of tell it to like download the Solar artifact and start Solar in Docker, and it does the sort of entry point sort of thing. And so this Docker Compose doesn't really need to be a Docker Compose because it's just one container now. Initially, it started out meant to be sort of paired with the web interface that wasn't necessary. The other option is that maybe we can sort of hide this in the command line tool, and you just be able to say like you pipx install Monarch Pi, and then you just run like Monarch Neo4j start or whatever, and it will just sort of download, start up a Docker container, and kind of go from there. And I feel like that would be the friendliest and sort of what would be nicer to get to.
Wow. Never thought of that. That's also a cool idea, especially for our target group is like, more data scientists type people. And I think for this, it would make some sense to make it as simple as that.
Yeah.
Although the Docker dependency is something that, keeps like splitting the people we talk to like into pieces. Like some people are like, why do we have all these Docker dependencies everywhere? And it would probably be not a bad idea if you were to write such a CLI that allows us to do this real quick, that it supports a non-Docker mode as well by supplying a path to a local Neo4j database, for example, as a command line parameter. Right.
And just a sort of quick plug for our command line tool. This is using it. It will work with Solar, but then also with the SQLite database artifact. And so head over to our releases directory. So these are the different artifacts we have are the straight TSV files, the Neo4j dump, SQLite database, and then a Solar dump, Solar data directory. And so the other direction we're going on is sort of being able to use either SQL or Solar to sort of get content out from just the command line. And right now there's just entity and association.
When you're mentioning Solar in this context, so is that the intention was to be able to index like the contents of the Neo4j database, or would that just be pointed back at like the larger source Monarch model?
It indexes from the TSV files. Actually, there's a sort of denormalized schema that brings in actually, since I have it on the screen, well, it should be populating things like the on an edge, the subject category and the object category and the subject and object label, that sort of thing.
Okay.
Like that example very much, but it spreads it out. It denormalizes a little, and I think it has the closures in it, which are sort of an important thing for Solar in the web interface. But roughly speaking, they're all the same thing. It's just that the standard KGX format is not the denormalized edges. And the Neo4j is also not the denormalized edges. So it doesn't have those extra fields on it. And then the SQLite artifact has both inside, and the Solar is just the sort of denormalized version. and we're working towards TSV output and other sort of endpoints, that sort of thing. But sorry, I'm drifting a little from Neo4j because I've been spending a little time on the command line interface. So that's what I'm excited about. Did you have other technical questions? Okay.
Yeah, I was. I think that this question already answered a few of my questions. I was primarily interested in the step that creates the knowledge graph that we are loading and we are seeing here compared to the ingestibles, but we don't have much time now, and I think that this is too far out of the scope of this session. So I'd rather just spend the last 2 minutes just thanking you once more, and maybe we can organize a follow-up session at some point in the in a few months, like 3-4 months or something, where we can do a little bit more advanced graph exploration tasks. And yeah, so maybe combined with the launch of the new UI or something. And hopefully many of you here will actually take the time to follow this tutorial and try this. I mean, this is super cool. And if you have any feedback on the graph, like the thing that we just saw with the risk factor and the gene, it's also very good for to have like a more eyes on the graph than just, 2-3 people that are working all non-stop on the graph, I think. So yeah, that's it.
Yeah, absolutely. Yeah, message me on Slack or make GitHub issues for anything you see or want to know how to do.